Hello everyone, welcome to today's lecture. So we have finished with the first part of the chapter, heat. We studied about latent heat and anomalous behavior of water. Now today we are moving on to some terms, okay, some definitions which are there in the textbook, some points. The first one is humidity. Okay, the first one is humidity. You might have heard about the term humidity. You may take page number 66, heading dew point and humidity. About 71% of the surface of the earth is covered with water. Due to constant evaporation of water, water vapor is present in the atmosphere. So we all know that water vapor is present in the atmosphere. The amount the amount of water vapor in the atmosphere help us to understand the state of daily weather. The presence of water vapor in the air makes it moist. Now, what is the necessity of water vapor in the atmosphere? Is it needed or not? Yes, it is needed. If there is less amount of water vapor, then the air will become dry and it will affect the skin of all the living organisms. Okay, so moisture is important in the atmosphere. And what is that moisture called as? It is called as humidity. So the next sentence is the first definition. What is humidity? It is the moisture in the air is called as humidity. Now we may move on to the next term, next paragraph. For a given volume of air at a specific temperature, there is a limit on how much water vapor the air can contain. If the amount exceeds this limit, the excess water vapor converts into water droplets. When the air contains maximum possible water vapor, it is said to be saturated with water vapor. That is the next term, that is saturated with water vapor. What is saturated with water vapor? When the air contains, there is a particular amount of air, you can consider a little volume of air. If in that little volume of air, it contains the maximum amount of water vapor which it can contain, then it is said to be saturated with water vapor. The normal meaning of the term saturated. Saturated means which is enough. Okay, the maximum limit, that is said to be saturated. So if a given volume of air is containing the maximum amount of water vapor in it, then it is said to be saturated with water vapor. If there is excess amount of water vapor in that particular volume of air, then that water vapor will get converted into water droplets. Okay, if there is more amount of water vapor than the saturated limit, then the excess whatever it is, it will get converted into water vapor. Okay, sorry, water. Now next statement. The amount of vapor needed to saturate the air depends on the temperature of the air. So how much is saturated? It is decided by the temperature of the air. If more the temperature, more amount of water vapor could be included in it. Less the temperature, less amount of water vapor could be included in it. That means in rainy season, as the temperature is less amount of water vapor could be included in it, and the remaining becomes excess and it is converted into water droplets, and we feel that the conditions are very much humid. That means humidity increases, means the water vapor content increases, the moisture content increases. Now the next, for example, if temperature of air is 40 degrees Celsius, it can contain 49 grams of water vapor per kilogram of dry air without condensation. If the amount of vapor exceeds this limit, the additional water vapor will condense. However, if the temperature of air is 20 degrees Celsius, it can contain only 14.7 grams of water vapor per kilogram of dry air without condensing. That means as the temperature decreases, the amount of water vapor which is maximum limit, that also decreases. Okay, for example, there is a particular classroom and the maximum limit of that particular classroom is about 45 students. Consider maximum 45 students can sit in the class. Okay, there is a particular classroom. So what is the capacity? The capacity is 45 students. Okay, whatever will be excess, if more students come on that day, whatever will be excess, they will be out of the class, isn't it? They won't get the place to sit. What will happen to those water vapors? If there are water vapor which are in excess, they will get converted into water droplets. So if there is a particular room, consider, and there is a particular volume and there is a particular limit of water vapor which could be included in that room. Understood? If it is in excess, it will get converted into water. Okay, and if the maximum limit is not there, then it is said to be unsaturated. Now we will see what is unsaturated. If the water vapor contained in air is less than its maximum limit, then the air is said to be unsaturated. Hope you have understood saturated and unsaturated. Saturated means which is having the maximum limit, and if it is below the maximum limit, then it is said to be unsaturated. Okay, now the next is dew point. Now I told you the example of a class. Okay, now there is a particular room. The capacity of that room is 45 students. There is a particular classroom. The capacity of that classroom is 45 students. If we reduce the size of the room, what will happen? The number of students who will be able to sit in that class will reduce. Okay, if you reduce the size of the classroom, the number of students who can sit in the classroom will decrease, isn't it? And what will happen to the extra? Those extra will be out. Okay, those extra will be out. Here the same example you may apply in your heads and apply it here. What is dew point? Suppose unsaturated air at a certain temperature is taken. There is a particular volume of air taken and it is unsaturated, and its temperature is decreased. Its temperature is decreased means you are decreasing the size of the classroom. Okay, so the unsaturated is already unsaturated, means it is having less amount of water vapor in the atmosphere, and even if you are increasing the temperature, going on in decreasing the temperature, then what will happen? If the temperature is decreased, a temperature is reached at which air becomes saturated with water vapor. This is called the dew point temperature. You might have heard about the topic dew, about the term dew. Okay, dew you might have seen on leaves in the mornings. Okay, water droplets on the leaves in the mornings, it is said to be dew. Okay, now we will see why it happens. So here you may see, I will again explain with another example. There is a classroom who is having the maximum capacity of the classroom is 45 students, but there are 35 students in the class, and you are going to decrease the size of the classroom. When you are decreasing the size of the classroom, okay, a point will reach when the 35 will be the maximum. Okay, I repeat, there is a classroom. The maximum number of students who can sit in that classroom is 45. Now what we are going to do, we are going to decrease the size of the classroom. When you decrease the size of the classroom, the maximum number of students which it could include, it is about 35 students. When it reaches that 35, whatever there are in excess, they will be out. Okay, they won't be able to sit in that class. Okay, so those extra, in case of humidity, it gets converted into water. I repeat, there is a particular amount of air. If you are the water vapor content in that air is already less. Now what you are going to do, the temperature you are going to decrease. When you are decreasing the temperature, a point will reach when that volume of air is becomes saturated with water vapor. If you again decrease the temperature, what will happen? The excess amount of water vapor will get converted into water. That point is called as dew point. So what is dew point? You may write this statement. Suppose unsaturated air in a certain temperature is taken and its temperature is decreased. A temperature is reached at which air becomes saturated with vapor. This is called dew point temperature. So below the dew point, dew is formed. Now the next term is absolute humidity. What is absolute humidity? The mass of vapor present in a unit volume of air is called as absolute humidity. If you have taken a particular volume of air, then the mass of water vapor which is present in it, it is said to be absolute humidity. Now what is relative humidity? Relative humidity is the ratio of actual mass of water vapor content in the air for a given volume and temperature to that required to make the air saturated with water vapor at that temperature is called related humidity. So there is a particular volume. Consider you are sitting in a room now. In that room, what is the actual amount of water vapor present in it upon the maximum amount of water vapor which could be present in it multiplied by 100. That is relative humidity. So what is relative humidity? The ratio of actual mass of water vapor content in the air for a given volume and temperature to that required to make the air saturated with water vapor at that temperature is called relative humidity. Percentage relative humidity is equal to actual mass of water vapor content multiplied by 100 upon mass of water vapor needed to make it saturated. Okay, so what is relative humidity? Relative humidity means actual mass of water vapor present upon mass required to make it saturated multiplied by 100. These are the terms which are important from page number 66. You may mark it accordingly in your textbook. Now you may move on to page number 67. The relative humidity at dew point is 100%. Underline, it is an objective. If the relative humidity is more than 60%, we feel that the air is humid. Again, I fill in the blank. If the relative humidity is more than 60%, then we feel that the air is humid. If the relative humidity is less than 60%, we feel that the air is dry. So nowadays, as the rain is falling, the humidity of our air is more than 60%. Okay, so that there are three fill in the blanks there, you may mark. Now there is a question on in the next paragraph about the white trail at the back of a flying plane in a clear sky. First you may copy this. Okay, now the next is a white trail at the back of a flying plane in a clear sky. I will read out the paragraph first. During winter season, you may have observed a white trail at the back of a flying plane in a clear sky. As the plane flies, the vapor released by the aeroplane engine condenses and form clouds. If the surrounding air is having more relative humidity, it takes a longer time for the white trail formed by the condensation of vapor to disappear. If the relative humidity of the surrounding is less, either the size of the white trail may be small or it may not even get formed. Okay, so you might have seen the white trail behind the aeroplanes after they fly away. Okay, so what is the reason for that? The reason is, as the plane flies, the vapors released by the engine condenses and form clouds. So that is the white colored trail which we see. More amount of relative humidity. If there is more amount of relative humidity in the atmosphere, that means if there is more amount of water vapor in the atmosphere, there is already more amount of water vapor, and if the plane is releasing again more amount of water vapor, plus it is an addition. Okay, already there is more amount of water vapor, again more amount of water vapor is given, then what will happen? It will take long time for the condensation of the vapor to water droplets. Okay, due to which it will take time to disappear. Okay, what to disappear? That trail to disappear. So the trail will remain for a longer time if there is more amount of relative humidity. If there is less amount of relative humidity, then it will take less time. Why? Because there is less amount of water vapor in the atmosphere, and the engine is putting again water vapor. Then that water vapor will immediately get converted into water droplets. Okay, due to which the trail may be small or may not even form. Okay, so this is about white trail. Now page number 67, try this. Take a bottle of cold water out of a refrigerator and keep it outside for a while. Observe the outer surface of the bottle. What will happen to the bottle? In the next statement, they have given drops of water can be observed on the outer surface of the bottle. In the same way, if we observe the leaves of plants or grass or window of glass of a vehicle in the early morning, we see water droplets collected on the outer surface. You might have observed this. What is the reason for that? When the air cools, this is the reason. When the air cools, due to decrease in temperature, it becomes saturated with water vapor. As a result, the excess water vapor gets converted into tiny droplets. So the dew point is reached. What is the dew point? The point at which there is maximum amount of water vapor. So as the temperature decreases, the dew point is reached and the dew is formed. Okay, that is the answer. Now there are two units for heat. One is in calorie and other is in kilocalorie. What is the definition of 1 calorie of heat? We may see the amount of heat necessary to raise temperature of 1 gram of water by 1 degree Celsius. Okay, to raise the temperature of 1 gram of water by 1 degree Celsius from 14.5 to 15.5 degrees Celsius is called 1 calorie heat. Okay, so what is 1 calorie heat? It is the amount of heat needed to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. The next definition is the same, only difference is instead of 1 gram there is 1 kilogram. Okay, so you may see instead of 1 gram there is 1 kilogram. What is the definition? The amount of heat energy necessary to raise the temperature of 1 kg of water by 1 degree Celsius from 14.5 degrees Celsius to 15.5 degrees Celsius is called 1 kilocalorie of heat. So what is 1 kilocalorie of heat? The amount of heat necessary to raise the temperature of 1 kilogram of water by 1 degree Celsius. And how much is that 1 degree Celsius? It is from 14.5 degrees Celsius to 15.5 degrees Celsius. Now the question will arise in your mind, why 14.5 to 15.5? Okay. Now it is a standardized temperature because the values might differ at different places on the surface of the earth at other temperatures. Okay, at other temperatures. For example, when scientists are doing research or some experiments here in India, consider they are taking the temperature from 20 degrees Celsius to 21 degrees Celsius, and in other countries, consider America, they are taking the temperature 37 to 38 degrees Celsius. Then the readings which they are getting might differ. Okay, they might differ, due to which the conclusions of those experiments might differ and there will be controversy. So to prevent that, the scientists have selected a particular range, that is 14.5 to 15.5 degree Celsius. Okay, now there is a box on page number 67. Always remember, that is the answer for that. If we heat 1 kg of water by 1 degree Celsius in different temperature range than 14.5 to 15.5 degrees Celsius, the amount of heat required will be slightly different. It is therefore essential to define a specific temperature range while defining the unit of heat. Calorie and joule are related by the following relation. 1 calorie is equal to 4.18 joules. You may mark that it is a very important fill in the blank. 1 calorie is equal to 4.18 joule. Okay, so this question which is in the box, it is very important. The give reason which is there in the exercise you have to learn. So have you understood why they take the temperature from 14.5 to 15.5? Because at other temperatures the reading might vary. So to keep it standardized, the temperature 14.5 to 15.5 is taken. So what is 1 kilocalorie heat? It is the amount of heat energy necessary to raise the temperature of 1 kg of water by 1 degree Celsius from 14.5 to 15.5 degree Celsius. Okay, and how much is 1 kilocalorie? 1 kilocalorie is equal to 1000 calories. So today you have to learn all these definitions. I will give you the homework. So this is the homework for today. Define humidity. Saturated with water vapor, what do you mean by a particular amount of air saturated with water vapor? Particular amount of air unsaturated with water vapor. Absolute humidity, relative humidity, 1 calorie heat and 1 kilocalorie heat. All these definitions are very important. You may write the answer and learn it. Okay, thank you.